Hello everyone and welcome back to Anupam Tech Talk. In today's episode, we are going to talk about a concept that is critical for building a reliable systems, idempotency. What happens when a user taps payment button twice or when the network failure after a payment is processed and the mobile application retries the same request. Without proper design, the same operation could potentially happen twice. So, today let's understand what idempotency is, why it matters, and how it helps us build a reliable distributed system. Let's start with a real world scenario. A user clicks payment button twice on the mobile application. The request is sent, but then a network timeout occurs. The application does not know if the payment succeeded or failed. So, what does it do? It retries. But here is a critical question. Could the payment happens twice? If the first request actually succeeded, but the response was lost, the retry could create a duplicate payment. This is exactly the kind of problem idempotency helps us to solve. Now, you might wonder, why do you even need retries? The retry is that networks fail, timeouts happens, connections get lost, servers experiences delays, apps gets interrupted. Temporary failure are common in distributed systems. Retrying the necessary mechanism to improve reliability. But here is the trade-off. Retries can create a duplicate. If an operation has side effects like charging a payment or creating order, a retry could execute that operation multiple times. This is where idempotency becomes essential. So, what exactly is idempotency? An operation is idempotent when operating the same request produces the same intended result. Think of it like this way. If I send a request A once, I get result X. If I send request A again, the exact same result I should still get, which is result X. Now, not a different result or a duplicate effort. In simple terms, same operation does not equal duplicate effort. This property makes the retries safe because even if the request is repeated, the system's state does not change beyond the first execution. Let's look at the practical payment example. Imagine we are making a post request to create a payment of rupees 1000. Along with the payment details, we included an idempotency key. For example, ABC123. When the server receives the first request with the key, it creates the payment and stores the key. Now, if the client retries the same idempotency key, the server recognized it. Instead of creating another payment, the server returns the existing payment response. The key inside. The same key means the same logical operation. So we return the same result instead of executing again. So let's talk about what happens without idempotency. The client sends a payment request of rupees 1000. The server processed it successfully, but then a network timeout occurred before the response reaches to client. The client does not know whether payment was succeeded. So it retries. The server receives the retry as a new request because there was no idempotency key to identify it as a duplicate. So it processed another payment of rupees 1000. Result 2000 charge instead of 1000. This is a real problem that can happen in the production system without proper idempotency design. So let's talk about what happens with idempotency. Now let's see the same scenario with the idempotency key. The client sends a payment request with idempotency key ABC123. The server processes the payment and stores the key along with the response. When the network timeout happens and the client retries the same key, the server checks, has this key been processed? The answer is yes. So instead of processing again, the server simply returns the previous result. So what is the result? Only one payment of rupees 1000, even though the same request was sent twice. This is the power of idempotency. So let's talk about where is the idempotency useful. Payments to prevent duplicate charges, order creation to avoid duplicate orders, booking system to prevent duplicate bookings, sending messages to avoid duplicate notifications, distributed APIs, any operations with side effects, retry mechanism, anywhere retries are possible. The key idea is simple. If an operation can be retried, think about idempotency. Any operation that creates, charges, books, or sends something should be designed with idempotency in mind. Here is an important point. Idempotency is not just a front-end problem. Retry can happen at multiple layers. The mobile application might retry, the API gateway might retry, the server might retry when calling the database, the payment service might retry when calling the payment provider. Each of these layers could potentially create duplicates if not designed properly. So the key idea is design the entire flow, not just the UI. Idempotency should be considered at every layer where retries can occur, essentially for the operations with side effects. And this brings us to an important engineering mindset. We should not just ask what happens when everything works. We should ask what happens when the request is repeated. What happens on success, on failure, on timeout, on retry, on duplicate request. Reliable systems are designed for failure. We know networks will fail. We know retries will happen. We know duplicate requests will occur. So instead of hoping they don't happen, we design our system to handle them safely. That's the idempotency mindset. Let us quickly summarize today's episode. First, network fails. That's the reality of distributed system. Second, system retry. That's necessary for the reliable system. Third, retries can create duplicate actions. That's the problem. Fourth, idempotency makes repeated requests safe. That's the solution. Fifth, use unique idempotency keys where appropriate, essentially for the operations with side effects. And finally, design for failure, not just for success. That's the engineering mindset. These principles helps us build system that remains reliable even when things do not go as planned. And that's it for today's episode. Idempotency may seem like a technical detail, but it's fundamental concepts for building a reliable distributed system. Wherever you are working on payment, orders, bookings, or any operation with side effects, idempotency helps ensure that retries do not create unintended consequences. And I'll leave you with today's thought. Reliable system do not assume requests happen only once. If you found this episode useful, please like the video, subscribe to Anupam Tech Talk, and share it with someone who might find this useful. I'll see you with the next episode where we will continue exploring practical engineering concepts. Thank you for watching.